So let's do some streaming. Okay, so I got another question. From a student, or I should say a set of questions from a student. So we're going to work on it today. Just sending student stream link. Message. Okay, here. All right. So this is the first one, and we want to make sure that this actually has the right edges. Some stuff got bumped around. Clean this up a little bit. Got that. So what I'm going to do this thing. Tell where it's at. All right. Now cooking with gas. Oops. You hear the dog going crazy. My apologies, because he is crazy and he will go crazy during my live stream. Okay, so this one is a fill in the blank question, and when I looked this up, the answer that I found, this is something that I've looked up a bunch of times before, because it's not commonly used, this method of giving direction, since we're not swashbuckling pirates from the 1700s anymore, so we just don't use this. The answer said that it was the direction, like let's say we have some direction like this, it's given from the north and opens clockwise, okay? But this website tells us that it's from the north or south. So this question here, this answer here, from the north or south, and it opens to the east or west. So that's the answer for this one. And you'll actually see throughout this problem set, this is going to be used. So get ready and excited for that. So that's the first one. And we're just going to kind of go down this list one at a time. I gotta like resize everything as we go, so I apologize in advance for that, but this is what we got. And I don't super want to deal with this like as a rotation. Okay, what are we gonna do? It's not what we want. But this is the state of things, so this is what we're working with. And these are going to get kind of like small and hard to read. Did I transition this thing? Yeah, I did. Okay. No, I did not transition this thing. So hopefully you can see that last one. The last one was north-south for the first one, and it was east-west for the second one. I'm still kind of getting used to these tools like OBS and everything. So I'm not the best streamer that ever was, but we'll get there. And if you're watching this, share it with your classmates so that they can see the problems too. All right. So what do we have? The following problem involves directions in the form of bearing, which is what we discussed in the last problem. That's that method of direction giving, which we defined in this section. Remember that bearing is always measured from the north-south line. So this is an example of use the test to take the test, and I think that's how I figured out what they meant when I did it earlier today before the stream crashed and it didn't work. So that was a bummer. Okay, so the following problems, all right, so these instructions at the top here are going to be like in many of these questions, so I'm going to gloss over them. The town L is 19 miles due south of town N. So everything's going to be in relation to town N. So I'm going to say this is town N. And that's not north, this is town N. We're going to model these as points. Then we're going to go due south 19 miles, and we are going to arrive at town L. So this is town L here. This distance, which I'll give by red line, is 19 miles. And then town B is due east of town L. So here I'm going to put like a faint yellow line here from town L to the east, because we don't know how far to the east this town is, but I know it's going to be somewhere along this line. Faint yellow line, I pressed. Okay, faint yellow line. So somewhere along this line, due east of town L, is going to be town B on this thing. And town B is also south 66 degrees east from town N. So if I am to make an angle from N, it's going to be south and 66 degrees. So let's try and just guesstimate this. Say if this is a 60-30, I don't know, something like this. All right. So this from the south is 66 degrees to the east. That is 66 degrees right there. So that's how you would read that. And so that means that the intersection of this line and the red line that I just drew in the yellow line is town B here. Okay. So we want to know how far is town L from town B, the length of this side of this triangle here, which I'll call x. Just since we don't know what it is, I just give it a variable. Okay, so I can see that x is opposite of 66 and that 19 is adjacent to 66. And I know that the tangent is going to, the tangent of 66 is then going to be x over 19. Since it's the opposite over adjacent. So I can use this equation to solve for x here. And then I'll multiply both sides by 19. So times by 19 on both sides. And I find that x is equal to 19 tangent of 66 degrees. Okay, and then so on my calculator, I'm just going to check and make sure I'm in degrees, and I am, and then I'll punch this in. 19 tangent of 66 degrees, and the answer tells us to round to, and with whatever this Webassign and Pearson, I forget what Pearson's product is called, all of those things, Cognity, all of them, you want to make sure that you follow the instructions when you enter this. So this is round to the nearest whole number. So I got 42.6746, yada, yada, yada. Round to the nearest whole number, I get 43. 43 is the answer to this one. And we're going to try and keep it moving pretty quickly here because I'm up late and I'm ready for bed. So I'm just going to go on. All right, let me see what is this the next one? I've got a bunch of these things open, so I'm just going to try and... All right, so this is our next one. Now, this problem is actually extremely similar to the last. Oh, I should mention, if anyone has any comments, I see we got a couple of viewers going at once. Go ahead and comment in the chat if you have any questions. And I'll try to get to all of them. as they come. All right, so I'm kind of resizing everything here. If you submit questions to me, try and scrunch your window like narrow horizontally. That'll resize the text. That'll force the website to wrap the text in your browser, and that'll make it a lot easier for me to fit it on the screen here, because I have a pretty, like, my screen is huge, but I only have so much room to work with on the stream. Okay, so here we go. So the same instructions as that first line. They're going to use the bearing convention to give direction. So a boat leaves the harbor entrance and travels 24 miles north, 44 degrees east. So from the north, you go 44 degrees east. That's this angle right here. And on that bearing, they go 24 miles to this point here. Then the captain turns the boat 90 degrees and goes another 18 miles. So that gives us this side length here. And that means that this angle is 90 degrees. So hopefully you can see that. Let me put that in red so you can see it a little bit easily. So that's 90 degrees there. And so they say he makes a 90-degree turn, then they give that direction, that south 46 east here. And I think this is actually a distractor. I don't think I used that information at all. So at that time, how far is the boat from the harbor entrance? So what they're talking about is this point here. They want to know how far it is from the harbor entrance, which is here. So that's the distance x. So we need to find x. Okay, so understanding that we've got a right angle there, we can just use right triangle trigonometry to figure this out. I have two sides and I'm trying to find the third side. So this is a really nice case for the Pythagorean theorem. So I can say that x squared, which is the hypotenuse, it's opposite of the right angle, so it's the hypotenuse, is equal to 24 squared plus 18 squared. And so that means x is equal to the square root of 24 squared plus 18 squared. Okay, so this is going to be 2 times 12 squared, which is 4 times 144. And this is 2 times 9 squared, which is 4 times 81 square rooted. And so what do we get? 400 plus 16 is 560, 76, 576. So 400 plus 160 plus 16, yeah. And this is 324. And add those together and they're equal to 900, which makes this equal to 30. So side x is equal to 30. And that is the distance from the 2 points that we're asking. So 30. So that's how far away from how far away from the harbor they are at that time that they gave us. And then we want to know the bearing from the harbor, the bearing from the harbor to where the boat is currently at that point that we just found the distance to. So we need to figure out this little angle here. Let's call it theta. And we're going to add that to 44. So this is equal to theta plus 44. That's what we're looking for. The way that we can do that is we can say that the tangent of theta is equal to 18 divided by 24. And then I'm just going to go ahead and reduce this 18 over 24. That's going to be 3/4. So now I can take the inverse tangent of both sides, and I get theta equals the tangent inverse of 3/4. So when you take the tangent inverse of tangent, it cancels, and you're just left with whatever's inside there. Oh, hey Louisa. I guess you can hear me, so I don't need to type back to you. If you have any questions, please feel free to post them. I wish there was some way I could turn an audio alert on here. Can I? I don't know. Okay, well, let's put the timestamp on. Okay, so it only took me 4 minutes to realize you had sent a message. Hello, thank you for joining. Okay, so the tangent inverse of 34 is going to give us theta, but we actually don't want theta. We want theta plus 44. So let me add 44 to both sides. And so our actual answer is going to be the tan inverse of 3/4 plus 44. And this is what I'll enter into my calculator here. I already checked to make sure I was in degree mode. That's super important. So I'm going to hit second tangent, which gives me, or shift tangent on my calculator. This gives me the inverse. And then I'll do of 3/4. And then that is plus 44 to get my final answer, which is 88, or it's 80.8698 whatever degrees, and we would round to the nearest whole number. So that will give us 81 degrees. So from the north, we're going to go 81 degrees to the east. So if there are no questions on that, I will actually move on to the next one because I'm going to get this done quick. Okay, let's keep moving. All right, so let's see. Let me find out what things I had open already. So I can get rid of these. And then we want to bring in next one. All right, so here comes the next one. Let me just resize this. That's not what we want. So if you are taking screenshots off of one of these websites to send me problems, go ahead and just squish your window sideways. It'll wrap the text and it'll make it easier for this to fit on the screen. So otherwise I just have to do this on the stream, which is, like, I don't mind it, but I think people watching don't like it if they like the stream at all. So same instructions along the top. They're going to use this line of bearing way of giving directions. So a man wandering in the desert walks 2.4 miles in the direction south 31 west. So let's give ourselves north-south line, and actually let's do some axes. Okay, so let's say he just starts from the origin. Here he is. He starts here, and he's going to go south 31 degrees west. So that means from the south, we open up 31 degrees to the west. So from this point, he walks in this direction. Let's say that's about 31. I don't know. This angle here is 31 degrees. And he goes 24 miles. I don't really have a sense for how this is going to go. Maybe I should read the whole question first, but why not? Let's roll with it. So he goes to here. That means this is 2.4 miles. Okay. Then he turns 90 degrees and walks 3.3 miles in the north 58 degrees west. So from the north 59 degrees rather to the west. So that means he took a right turn. And he's going 90 degrees. Let's say that's 90 degrees, but 3 miles. And this is no longer to scale, but we're gonna roll with it. 90 degrees. This is 3.3 miles. At that time, how far is he from the starting point? Okay, so we want to know the length of this thing. That's the distance to the starting point. So since it's opposite of the right angle, that means it's the hypotenuse. And so if this is squished, I apologize. So we actually know 2 side lengths of the right triangle, so we can really, really easily find the hypotenuse here. So the hypotenuse squared is going to be equal to 3.3 squared plus 2.4 squared. That means h is equal to the square root of all that. Just take away these parentheses here. really need them. Okay, so what do we get? We get, this is going to be equal to 9 plus plus 1.8 plus 0.09 plus 4 plus 1.6 plus 0.16. And so what do we get? Got 13, 14, 15 plus 0.89 plus 1.49 plus 0.16. So this is 16, 17, 16 plus 5.65. So 16.65. Guess I got to enter it in the calculator anyway. So I'll just put it all in there. 3.3 squared plus 2.4 squared. 16.65, and then we actually want to take the square root of that. So it gives it to me in do we have to round? Yeah, we got to round. So this is 4. That's 4 miles. Okay. Let me clear this some space for us here. So we know h now. H is 4 miles-ish. That's rounded, so I won't use that in any of these calculations here. Then I need to find the bearing to the place. So that's the big angle here. Now, I got to realize that that's the smaller angle, theta, plus 31. So what I'm looking for is theta plus 31. Now, I can find theta using the tangent. The tangent of theta is equal to the opposite, which is 3.3 over 2.4. And so we can reduce that to be, this will be 11 over 4. Yeah, 11 over 8. And then we'll take the tangent inverse of both sides. Tangent inverse composed with tangent cancels out. And that'll be equal to the tangent inverse of 11 over 8. So and then you want to do the second tangent, and always check to make sure you're in the correct mode. I want to be in degrees, which I am, so I haven't changed it since I started. We're going to round to the nearest whole number according to the instructions. And so I want to make sure, I almost forgot actually, I want to add in that 31 degrees. So we get 85 here. Okay. So theta equaled 84, but probably what you should just do is add it in your calculator all at once. And so this thing is approximately 5 degrees. So just rounding to the nearest whole number like the instructions say. And if there are no questions, I think I'm the only one anymore. Well, it says there's one viewer, but I'm pretty sure that when Louisa was in here, that was our last one. So thank you for coming into the stream and saying hello. Okay, so let's import another frame and we'll go to the next one. Size this. Got that. It's a little bit bigger because it gets hard to read. So same instructions on the first line. It says a boat travels on a course of north 36 degrees, 10 minutes west. So here's our north-south line, and our boat starts, let's say here, and they travel from north 36 degrees 10 minutes to the west, which let's say that's approximately here. So this is 6 is 10 minutes. And then they do that for 78.2 miles. How many miles north and how many miles west has the boat traveled? So this is really asking us to like decompose this thing into north and west like it was moving like taxi cab coordinates, which is a real thing. So they want us to find x and y. Okay, so we can do this. Keep in mind the 78.2 is the length of the side. That's the hypotenuse. And 36 degrees, 10 minutes, we actually want to find, we can use that to find this because this should be a right angle here. I made it to be a right angle there. So if we take 90 minus 36, we get 54. And we'll take another 10 degrees away from that. So actually what I have here is 53 degrees and 50 minutes. Then, oh, you know, I could have just used that angle here. So this is 3610 also. Okay. So now we have two angles and we have the hypotenuse. So we can use that to find the other. So let's just use this 3610. So I've got 36 degrees plus 10 minutes, essentially, okay? But I want to convert this 10 minutes to a decimal of degrees. So what I'll do is, I know that, so as an aside here, 1 degree equals 60 minutes. And so if 1 degree equals 60 minutes, I can divide both sides by 1 degree. Actually, I'm sorry. Divide both sides by 60 minutes. 60 minutes, and 60 minutes divided by 60 minutes is equal to 1. Now this is equal to 1, so that's a conversion factor. This thing is equal to 1. You can always multiply by 1. It doesn't actually change the quantity. It just changes the way it's written. It's an equivalent fraction, so to speak. Okay, so my minutes units cancel, and what I'm left with is 10 over 6 degrees, which is 1 over 6. Which is 0.16666. Okay, so this is 36 and 1/6 degree. Okay, that's our measurement for that angle. So I know that the sine of this, or actually let's use tangent. So the tangent of that angle, let's call it theta, just to make this easier. The tangent of theta is equal to x over, no, we do want the sine. So this is theta. Because I know the hypotenuse, that's the side that I know. So the sine of theta equals x over the hypotenuse, which is 78.2. So to find x, I multiply both sides by 78.2, and I get x equals the sine of theta, let's put 78 first, so 78.2 times sine of theta. And theta is that 36 plus 1/6 degrees. So this I'll put into my calculator, 78.2 sine of it's 46.148 per miles. What do we round to the nearest tenth? So we're going to get west. So x is west. and it's 46.1 miles. And I actually am going to enter this another way just to check it. So 46.1. So we're going to do so 78.2 sine. Okay, 46.1. All right, so I just wanted to check I'm not using my normal calculator. And then so we can make the cosine the y. So the cosine of theta equals y over 78.2. And same procedure, we'll multiply both sides by 78.2. And we get y equals 78.2 times the cosine of theta. And that theta is the 36 plus 1/6. So it's really easy. I can just go back to the original, the thing I just typed, and change that for cosine. And so we get 63.1. And if you square those two things and add them and the square root it should be approximately 78.2 because we did round. But I'm actually going to do that since somebody is going to be like relying on this. I want to make sure that it's it's as good as possible. Do all the checks I can. Okay, and so I got 78.146, but I did round both of those figures. So hopefully, if I had the same thing. Oh yeah. So, and you can see why, right? Like if y squared plus x squared is supposed to equal to 78.2. That's the goal, right? Well, y is 78.2, I'm sorry, 78.2 squared. 78.2 times the cosine of theta, okay, squared. And then x squared is 78.2 times the sine of theta squared. And so we could factor out that 78.2 squared. Just bring it up here. We'll get 78.2 squared times the cosine squared theta plus sine squared theta. And of course, this is equal to 1, and 78.2 squared is equal to 78.2 squared. So it works out. That's just the Pythagorean identity. So there's your answer. We did a check. And we are going to keep going. Let me... If for whatever reason the stream drops out, I am going to immediately start up another stream and keep going. I don't want to stay up all night, but I do want to get this done. So, okay, here we go. Next problem. So, all right, so I kind of cut off the word door in this problem when I took the screenshot, but that's okay. I'll just try to read it. Okay, so this says from a point on the floor, the angle of elevation to the top of the door is 51 degrees. And you see that here. So from the floor to the top of the door, that's the angle of elevation, is 51 degrees. While the angle of elevation to the ceiling from that same point is 58 degrees. That's the big angle here. If the ceiling is 8.7 feet above the floor, once you find that information here, what is the vertical dimension of the door? So the height of the door. That's given by x. So this is hard to read, so we can kind of like flatten this a little bit and make it a little easier. So to the top of the door is here. Actually, let me do the vertical first. Okay, so this is not to scale, so don't be disappointed if you're expecting drawing. So this is kind of like, I reoriented it so it's facing us. And so this angle here is 51 degrees. And then this angle here is 58 degrees. This is 90, since it's a wall. The height of the door is the shorter one, x. And then this taller one here is 8.7 feet. So essentially what you've got is two triangles. And they share a portion of one side, and then they share this full bottom thing. So because they share the bottom thing, like I want to find that. I'm going to call it k. Doesn't have a variable yet. So since we know the 8.7 and the 58 degrees, I'm going to use that to find k. So the 58 is opposite of the 8.7 and adjacent to the k. So that means we can use tangent. So the tangent of 58 degrees is equal to 8.7 over k. So I'll multiply both sides by k here and then divide by the tangent of 58. And I get k is equal to 8.7 divided by the tangent of 58 degrees. And you can plug this into your calculator. We actually don't need k as the answer. We're looking for x. I just need k to get to x. So I'm going to leave k just like this. In fact, let me take this thing, and I'll just, oh, we don't want to do that. Don't want that at all. Selection tool. Okay. I'm going to take this thing, and then I'm going to move it. How does one do it? That's the whole canvas. We don't know. So I'm going to move the selection. Selection. Is it the same thing? Ah, it is the same thing. Okay. There it is. Okay. For anybody who is not using this software, you should. It's cool. All right, so that's k. I'm going to use k in the next expression since I've got it right here. I might as well just write that instead of doing all of this over again. So like this, I can say that the tangent of 51, that's the smaller angle, okay, which is in the smaller triangle, is equal to x divided by k. So x is opposite of 51, and k is adjacent to it. Then I can do the same thing. I want to solve for x. I'm going to multiply both sides by k. I know k. It's important to realize that. So x is equal to k times the tangent of 51 degrees. Okay. Then I'm going to substitute back in my k. 8.7 times the tangent of 51 divided by the tangent of 58. And this is what will go in my calculator. And I'm getting 6.7 and some change. This one wants us to round to one decimal place, so this is 6.7 feet. And that makes sense. Like, I should expect that it would be smaller than 8.7. So, you know, that's a nice check, is use your spatial reasoning to make sure that the door is shorter than the ceiling. Okay, let me check the live stream. Okay, no questions in the live stream. I don't even think my student is watching anymore, which is a bummer. Hopefully, I'm able to make use of this. She'll watch it all at the end. All right, so going to the next one. We did that. That is this one. Moving along. Okay. This is incredibly hard to read. Okay, so a man standing, so I've done this problem before, and there's an issue with this problem, which we can see. So it says a man standing on the roof of a building 58 feet high looks down to the building next door. So let's draw a building. Let's make it blue, partial to blue. Here's a building. Okay. And there's a little fella, he's standing on top here. This building is 58 feet tall. This guy is looking down to the building next door, which is also a blue building. And we're going to assume that these two buildings are on the same level of ground. He finds that the angle of depression to the roof of that building, the building next door, from the roof of his building is 34 degrees of depression. So this one. This is supposed to be 34.7 degrees. And then while the angle of depression from the roof of his building to the bottom of the building next door is 63 degrees. So this is impossible right here. This is 63 degrees. So there's only a couple of things that could be going on. They generate these numbers programmatically. So essentially what they do is they write this question, and then all of the red numbers get randomly generated. But they should be generated in such a way that they make a possible like scenario here, and the missing variable should be this. But this thing is done incorrectly at best. So what I think probably happened is they meant this to be the big angle, and then the other angle is meant to be the small angle. But it's really hard to say. WebAssign is not good. I think anybody who uses it knows that. It's buggy occasionally, and it is not good for your learning experience. So if you go to a college that uses WebAssign that doesn't teach you, go to a different college. Okay. So we want to find this other height of this building. So I'm going to assume that this is the right way. I don't know if this is right. It might be wrong. You may get the answer wrong, but this is the only thing that makes sense. So I'm going to go with this. All right, so something to realize is that we can form two triangles by connecting the bottom of these buildings. So just considering the distance between the buildings, we can make another side to a triangle. So there it is. And that's also the same as this. It's just the distance between the buildings, which is the same as long as you measure it across horizontally. So we can call that x, and that means this length here is also x. Okay. And I'm not going to label that for the moment. All right, so let's use what we know. We know this side here, 58. 58 is actually common, or is 58 is in this triangle, so we can use it to find x. So the sine of 34.7, I'm sorry, the tangent of 34.7 is equal to the opposite, which is x, over the adjacent, which is 58. And we can solve for x then. X is equal to 58 tangent of 34.7. Okay, so we know what x is now. You could just plug that into your calculator. I'm not going to do it yet. Which means that this red length, let me make this red. This red length is the same. That's also x. Make it red there too. And so since that side is involved with the 63.8, we can use that to find, let's say, this green side here. So this green, oh, that's not green at all. This green side here, you know, whatever this is, it's k. K plus y, which is the rest of this height, k plus y should be equal to 58. So I'm actually looking for y to answer the problem. So y is equal to 58 minus k. So I need to find k. And I can use that 63.6, which is this angle here, and the x, which we just found, which is the red side here, to find that using the tangent relationship. So k is what I'm looking for. The final answer is going to use this y equals 58 minus k. So that'll be our final answer, 58 minus k. So what does k equal? I know that the tangent of 63.6 is equal to x, which we found, over k. And so I'm solving for k here. So k is equal to x divided by the tangent of 63.6. And we know x, so I'll just substitute that in here. We've got 58 tangent of 34.7, that's what we found, divided by the tangent of 63.6. And let's go ahead and put that in. Let's see what that's equal to. I'm going to switch back to my calculator because I'm too tired to do this mistake-free. Okay, so I'm getting approximately 19.9, and we want to round to the nearest tenth, so you'll put 19.9 in here. And I make no guarantees about this. This may or may not be correct, but this problem's broken, so there's nothing we can do about it, unfortunately. Actually, I broke a cardinal rule. I did not check to see if I was in degrees. Okay, I was in degrees. We're all good to go. So I don't feel good about that one since we don't know if it was correct or not, but oh well. This next problem is actually the exact same problem. It just looks slightly different, which is nice. Just shrink that a lot. Okay, that doesn't make it much better, but it makes it a little better. So in the figure, a person standing at point A notices that the angle of elevation to the top of the antenna is 49 degrees 30 seconds. So that's here. 49 degrees 30 seconds is 49.5 degrees. A second person standing 40 feet farther from the antenna, so this distance here is 40, finds the angle of elevation at the top to be 43 degrees 10. So this angle in here is 43 degrees 10, which is 1/6. 43 degrees 10 minutes. How far is the person at A from the base? So we're going to find x here. So they share a common side, which is h. So let's find h first. Where actually angle no. So let's see, the tangent of 44.5 is equal to h over x, and the tangent of 43 1/6 degrees equals h over this bottom side here is 40 plus x. Okay, so both of these things have an x in them. or both of these things have an h in it. So I'm going to multiply this on both sides by x to get h. So I got h. And then I'm going to multiply this thing on both sides by 40 plus x to get h. Okay, why did I do that? The reason why I did that is now, since these are both equal to h, they can be equal to each other. So I can say that x tangent of 44.5 is equal to tangent of this times 40 plus x. So we're going to go tangent of 43 plus 1/6, okay, times 40, and then also times x. So I just distributed there. Actually, let me make another step. So I set these at this is this, and this is this. I just used the commutative property to switch these two. So the portion in brackets is here. Okay, now I'm going to distribute the tangent of 43 plus 1/6. So, and I'm going to change colors too because this is hard on the eyes. So x tangent of 44.5 is equal to tangent of 43 and 1/6 times 40. So I'll put that 40 out front, plus x times the tangent of 43 plus 1/6. So I just distributed. And then I'm solving for x, so I'm going to get all my x's on one side. So I'm going to subtract everything over to here and factor out the x. Minus and this is equal to what is left on the right side, which is 40 tangent of 1/6. And then I'll divide both sides by this to get x, which is equal to 40 tangent 43 plus 1/6 over tangent of 44.5 plus, or no, minus tangent. Okay, so let's throw all that into the calculator and we'll figure out what x is. So we've got 40 times the tangent of 43 plus 1/6. It's divided by tangent of 44.5 plus the tangent of 43 plus 1/6. Which is 838.8. Rounded to the nearest whole number is 839. Okay, so I'm a little light on the explanation. I do apologize. Oh, we got another viewer. Hopefully that's my student. Say hello in the chat if you want to. Welcome either way. Okay. Let's readjust this thing. Okay. So a satellite is circling A equals 114 miles above a planet. So this, in this diagram, the red circle looks like the surface of the planet, and A is the height above the planet, as shown in the figure. Okay. When the satellite is directly above B, that's a point on the surface, angle A, which is up here, is found to be 76.7 degrees. Use this information to find the radius of the planet. So angle A, they're calling it alpha. So they're using two names for this, and alpha equals 76.7 degrees. I'm not sure why they've done that, but that's really confusing. The radius of the planet is x. So let me actually draw this slightly better. We've got a planet. So here's our planet. And planets have radii. So the radius goes from the edge to the circle, and then to the center, and so on. Okay, so assume these are the same length. These are both the radius, which I'm going to call r for the moment. And then this line is actually extended out to some point in space. And then this line, which is a right angle, is here. So we've got a right angle, we've got a radius. This angle here is alpha equals 76.7 degrees. And then this side length here is called A, confusingly. Okay, so the tangent of 76.7 is equal to the opposite, which is r, over the adjacent, which is a plus r. I'm sorry, that's the hypotenuse. I'm using the wrong relationship. Okay, so the sine, rather, of 76.7 is equal to r over the hypotenuse, which is a plus r. And so we can solve for r here. This is a little tricky, but I'm going to multiply both sides of the equation by the denominator here, a plus r, and I'll get r equals sine of 76.7 times a plus r. So I just multiplied both sides by a plus r. It canceled over here, and then we're left with this. Now I can distribute sine of 76.7 to both of these. So r equals, let's say, a sine of 76.7, and we're looking for the radius. Oh, so we know a. That's another thing. A is equal to 114 miles. So we're looking for r. And then this, finishing this distribution. So I got the first part, and then I need to add r sine of 76.7. So sine of 76.7 is just a number. I'm going to subtract r sine of 76.7 from both sides, and then factor out the r, and I get r times 1 minus sine of 76.7. This is the same trick from last time. Equals a times sine of 76.7. And then I'll divide by this 1 minus sine of 76.7 on both sides. That gives me r equals a, which is 114 miles, times the sine of 76.7 divided by 1 minus the sine of 76.7. And this is something you can just throw into the calculator. 114 sine of 76.7 divided by 1 minus sine of 76.7. So I'm getting 4,136, round to the nearest whole number. So 4,136. And I don't know much about like satellites and orbits, but the distance from the surface of the Earth to the satellite is like 1/400th of the radius, approximately. So that seems a little bonkers to me, but like I feel pretty strongly that this is the right answer. And we round to the nearest whole number, so 4,136. Just like my physical intuition doesn't like that. But yeah, there we have it. Let me see what else we've got here. So we've done that one. We have done this one. A couple more. I don't know if I'm going to make it. It's 10:30. All right, a ship is anchored off a long straight shoreline that runs north and south. Okay, long and straight shoreline that runs north and south. From two observation points 10 miles apart on the shore, the bearings of the ship are this. Okay, so here is one line or one point of observation. Here's another point of observation. They are 10 miles apart. The line of bearing is north 34 degrees east. So we're going to go north 34 degrees east. It's going to be something like that. And then south 57 degrees east. Yeah, so that, I don't know if that's scale, but it's the best I could do. So this red point here is a ship. Oops. The red point here is a ship. And then I just constructed a horizontal line from that to the coast. And that's actually what they want. What is the shortest distance from the ship to the shore? So X here, this little line. Okay, so we know this angle, or we know this angle and we know this angle. So this one here is 34. This one here is 57. And then we know the X. So I wonder, let's see. Let's give this an unknown side here, K. And then K plus this thing, let's call it Y. So K plus Y equals 10. Which means we have K and Y equals 10 minus K. So we've got both of those in terms of K. I'm going to take this away. This is 10 minus K. So those are the two sides there. So we can make the tangent of 57 degrees equal to X over K. And then I can make the tangent of 34 degrees equal to X over 10 minus K. So now everything's in terms of X and K, and I can solve for X in both of these. So this one, if I multiply both sides, will give me X equals K times the tangent of 57. Actually, solve for X? No, I don't want to solve for X. I want to solve for K here. Let me solve for K. So this will give me k is equal to x divided by tangent of 57. And then this one gives me k is equal to 10 tan 34 minus x divided by tangent of 34. So boom. Yeah. So now I can set these things equal to each other. So I'm going to set these two. They're both equal to k, so that means they're equal to each other. So x over the tangent of 57 degrees is equal to 10 tangent of 34 minus x over tangent. And then we can use this to solve for x. So what will I do? I'm going to break this thing into two fractions. So since it has the same denominator, I can just separate the denominator. Okay, and these two will cancel, so it's just 10. So I'm going to add this to both sides. And I get x equals 10 times no, I should not be so silly about this. Just like do it. So starting from the point where I set k equal to, each of the k's equal to each other. Okay, so we'll get x times 1 over 10 7 plus 1 over 34 equals 10. So x equals 10 divided by okay, so this can go in the calculator. This is a mess, but 4.69. Round to the nearest tenth. So 4.7. Here, 4.7. That's our answer. Okay. Ah! That's awesome. Okay, so I don't know if whoever's still with us. Oh, it's just me and you, I think. There's always one viewer, and it's not me. It's probably like my nephew or something watching. But only active people are me and the student. So they said we got it right, so that's good. Okay, and I'm gonna keep going until I can't anymore. But I think we might be able to get this done. All right, so this is good. We're at the first problem in the second packet of stuff. So we finished that one. Onto this one. All right, I think we're probably finish this all. Okay, so back over here. So we've got the high roller located on the Las Vegas Strip in Paradise, Nevada is currently the largest observation wheel in the world with a diameter of 520 feet. So let's draw a wheel. And it has a diameter of 520 feet. So the top of the wheel stands 550 feet above the ground. So that means that this is 30 feet and this is 520 feet because that's the diameter here. So you can break that 520 into two. So that's 260 and 260. So 260 plus 260 plus 30 should give us 550, which is up to the top. Find the height of a rider after the wheel has rotated through an angle of 110 degrees. So I'm assuming that, they actually say that the rider boards at the bottom, so they start at the bottom here, and then they rotate through 110 degrees, which is more than 90, so it's like up here somewhere. I don't know, right there. Okay. So we've got this spot right here. We want to find that height. So that height goes to the ground. And so I'm going to draw a couple of horizontals here. I'm going to draw the horizontal from this to this. I'm going to draw a horizontal from this to this. Now, those red lines have the same length. And this is, this line segment down here is 30 itself. So what do we want to do? The place where this intersects here also has a radius. Oops. Do we need that information? So this is kind of sloppy looking. So this should be the same angle. There. Looks close enough. Okay. Okay, so this line segment here is 260. So we only need to find this little one here. If this is 110 degrees and this is 90, that means, I'm sorry, this is 110 degrees and this is 90. So 110 minus 90 makes this 20. And if this is a radius, that means this is a radius. This is 260 as well. So we can say that the sine of 260 equals x, the sine of 20 equals x over 260, which means that x is equal to 260 sine of 20. And we actually don't want x, we want x plus 30 plus 260. So we'll take x plus 260 plus 30 is 290, which is equal to 260 sine of 20 plus 290. And let's dump that into our calculator. 260 sine of 20 plus 290. So they are 298.8925. Oh, sorry. I missed a digit. 278.9. That's interesting. So I'm getting 278.9, which is approximately, they tell us to round to the nearest whole number, so 279, which is way too close to the, oh no, wait. 378.9, which is approximately 379, which is way too close to the answer they give to be a mistake. I think that one of us has a round off error, and so I put exact values into mine. So I think it's their problem. I think they rounded to the 10 instead of to the 1. So yeah, there you go. That's how you get it. We ended up not needing this like other radius here. And that's going to be like a pretty common theme with me, is like I really don't know how to solve this thing until I start trying. I've never done a problem like this before, so I didn't need that, but yeah. Oh well, we just didn't use it. Okay, so we're gonna there we go. See, these ones are nice and easy because they're like narrow horizontally. Hopefully the stream hasn't crashed. I should check. Okay, stream's still going. Okay, well, bit rate's not right. Okay, so a road up a hill makes an angle of 6.5 degrees with the horizontal. So a road up a hill, so here's the road, and here's the horizontal, and this is not to scale, but this thing is supposed to, this might be close, but I'm not sure. 6.5 degrees. If the road from the bottom of the hill to the top of the hill is 2.5 miles long, so this is our hypotenuse, how high is the hill? So everything, right, triangles, because that's what we're working on. So we want to know this distance. Let's call it y. So the sine of 6.5 degrees is equal to y over 2.5. And if we solve for y, we get y equals 2.5 times the sine of 6.5, which is calculator work. And we get, yeah, so it's 0.28 miles, okay. 0.28 miles, which is what they have here. And then let's go to the next one. And make this bigger. Okay, a ladder is leaning against the top of an 8.5-foot wall. If the bottom of the ladder is full wall, what is the angle between the ladder and the wall? Okay, so we've got a wall, and we've got a ladder leaning against the top of the wall. Super dangerous. Always leave yourself a little bit of a lip at the top of the wall. Give yourself like 3 feet above the wall. You have something to hold on to while you climb up over that edge of the wall. So the bottom of the ladder is 4.5 feet from the wall, and the wall is 8.5 feet tall. And so we want to know the angle that the ladder makes with the top of the wall, which is theta. And so we can say that the tangent of theta equals 4.5 over 8.5. So theta equals, so taking the tangent inverse of both sides, 4.5 over 8.5. And so that is what? 9 over 17? I'm just going to put it in like that so I don't get messed up. Second tangent of 5.5. 28 degrees. Okay. So these problems all have the answer here because this is like a study guide, I think. Okay. And 3 more to go. So Pat and Tim positioned themselves 2.5 miles apart to watch a missile launch from Vandenberg Air Force Base. When the missile is launched, Pat estimates its bearing to be yada yada yada. Okay. Southwest. Okay, so here is a north-south line and southwest and northwest. Okay, so here is Pat, and here is Tim, and Pat estimates it to be 75 degrees, so let's say this is 90, this is 45, so it's like right here. So I'm going to just extend the line because I don't know what the other angle will be. And then he's got his 65, so that's a little bit less. Okay, let's put it here. I don't know, that's fine. And then I'm going to construct a horizontal here, or the horizontal line here. Oh yeah, so Tim is due south from Pat. That was the only thing that could possibly make sense. How far is Tim from the missile when it's launched? So we want to find this distance. Draw a diagram and round the answer to the nearest tenth. Okay, so this angle is 75. This is 65. This distance here is 2.5, but I'm going to call this one K, and this is going to be 2.5 minus K. So let's say this is K and this is L, okay? K plus L equals 2.5, which means L equals 2.5 minus K. And so now we can take everything and put it in terms of K. And how I've done these problems a couple times already, it's like the same problem over and over and over again. So what do we know? So these share a side. Let's say that it's H. Or what do we need here? These share a side, and it's this H here. So let's say the sine of 70, or sorry, the tangent of 75 equals H over K, which means that H equals K times the tangent of 75. Well, maybe we don't even need that. Let me think about this. We use the other one. So the other one, we want the cosine of 65 to be equal to 2.5 minus K over X. So that's how we get X involved. So let me solve for X here. This gives us X equals 2.5 minus K over cosine of 65. So Yeah, we're going to need h. All right, so I need another set of equations. So let's say from the bottom triangle, I'm going to say the tangent of 65 equals h over 2.5 minus k. And then I can solve both of these for h, set them equal to each other to find k. From the top one, I get k times the tangent of 75, which is equal to tangent of 65 times 2.5 minus k. And then we can solve for k. So k is going to be equal to the tangent of 65 divided by, so this is 2.5 times tangent of 65, tangent divided by tangent of 75 plus the tangent of 65. Okay, so this is k. And so this, now that we have k, we can find this side here. And then we can say that the cosine of 65 from the bottom triangle equals 2.5 minus k over x, and I can use that to solve for so let me write here, cosine of 65 equals 2.5 minus k over x, and so x equals 2.5 minus k over the cosine of 65. And then we know k. K is here. So let's put this mess in the calculator. Not this calculator. Oh, let's use this. Okay. So we've got 0.5 minus tangent tangent 75 65 sine 65. So I'm getting 3.756. Yeah, so 3.8. And let's, just to be clear, like this k here is this k here. So when I typed this in, I substituted that. It's just a lot to write, so I didn't write it down. But that's how you would get it. Just make this substitution in for here when you actually enter that in your calculator. But it feels nice when it works out like that. Three more to go. Okay. Here. Okay, so if the angle of elevation of the sun is 73.4 degrees when a building casts a shadow of 37 5 feet. What is the height of the building to the nearest whole number? So yeah, if you haven't done this, then these kind of problems before, it would be kind of hard to know. So here's a building. We're looking for the height of the building, but I'm told that the shadow of this building, told the length of it is 37 feet. So I don't know how it's going to go. So that's 37 line, 37.5. And we also are told the angle of elevation. So this is not to scale whatsoever. The sun is 73.4 degrees. And we need to find h. So tangent of 73.4 degrees is equal to h over 37.5 feet. So h is equal to 37.5 times the tangent of 73.4. And I have no idea, so this would be $126. So this like angle of elevation thing is a big source of confusion for a lot of people when they're first seeing these problems. But you know, there's elevation and declination. Elevation is up, declination is down. So just roll, you'll be able to figure it out usually. Okay, and I'm just like cruising through these because I need to get it done and I want to go to sleep. I'm getting lucky because it's going really well. So a tree on one side of a river is due west of a rock on the other side of the river. So we're burned 210 yards north of the rock. So distance is the rock to the tree. What is the distance from the rock to the tree to the northeast hundredth of a yard? Okay, from the rock to the tree. So a tree is on one side of a river, and it's due west of a rock on the other side. So here's the river. Here is let's say a tree. We're gonna look from the top down. So oops. Here's the like canopy of the tree. That's our tree. And we've got a rock on the other side. Pretty big ground. Guess I didn't. Okay, rocks are brown, right? The tree is due west of the rock. So really we're modeling both of these with a point. Here to here. And we want to figure out what is the distance from the rock to the tree. From a barn 21 yards north of the rock. So there's a barn up here, and it's 21 north of the rock. And so we can just make a triangle. From the barn, the bearing of the tree, from the barn 21 yards on the north of the rock, the bearing of the tree is 18.2. So that is a horrible sentence. That's just like completely unintelligible. I think this one is 18.2. Bonkers. So what is the distance of the rock to the tree? So this distance here, let's call it x, is the distance we're looking for. So we'll do the sine of 18.2 equals x. Oh no, that's not sine. We don't want sine. We want the tangent. Equals 18.2 over 21. Oh, woof. The tangent of 18.2 equals x over 21. And so x equals 21 times the tangent of 18.2. And let's see if it works out. 21 times the tangent of 18.2. 6.9. yards. And they went to the hundredth, so 6.90. Okay, I think this is the last one. Let me actually check. Yes. So if that was, then yeah, that was hard. It was just a hard problem. And the hard part was like drawing the diagram, because that question was worded really, really oddly and just didn't make any sense. So if you found that to be difficult, welcome to the club. I thought it was tough too. Okay, so Pat and Tim positioned themselves 2.5 miles apart to watch a missile launch. Oh, is this the same question? Yeah, I think maybe we are done. So we did that. We did the road. We did the ladder. Building with the shadow, or the building with the sun and the shadow. We did the tree and the river. We did Pat and Tim already. Crushed it. Okay. That's it for me. Oh, YouTube is not mixed. What? YouTube. Well, hopefully that was just right at the end and everything made sense. Oh, that was way too long. Okay. Good night.